All right, let's go with part C. We have the definite integral 2x over x squared minus 4x plus 4. Let's go here. As always, I'm going to first consider this as a indefinite integral problem. Okay. So the bottom is a quadratic. Again, you may pause the video and then start thinking about what technique you can apply. And what I can see here is that maybe calling the bottom to be u may help because the derivative of the bottom will be 2x minus 4. Even though we don't have minus 4, we may sort of utilize that, but I want you to think about it before I start hitting the road. All right, so I think adding and subtracting is going to help. And the bottom is a very special quadratic, in fact. That is the quantity power of x minus 2. Now let me first convert that into like a perfect quadratic. And now we can do like adding and subtracting 4. So 2x minus 4, x squared minus 4x plus 4, plus, this is dx, right? 4 x squared minus 4x plus 4, but why don't we also replace that by x minus 2 squared? So in the first integral, I kept x squared minus 4x plus 4 as is because I want you guys to see that if I call the bottom to be u, the derivative is going to be 2x minus 4. Then that pops in the numerator. For the second one, we're going to use a different u substitution. Because you have 4 over x minus 2 quantity squared, I'm going to call u to be x minus 2 over there. So let's just do it. So these are separate u substitutions. So I'm going to use different colors for that purpose. So I'm going to use yellow here. So u to be x squared minus 4x plus 4, so that du equals 2x minus 4 dx. All right, over here, I'm going to use a green color and u to be called x minus 2, so that du equals dx. Okay. Let me continue up right here, okay, because I need space. There we go. So I have integral du is 2x minus 4 dx. It's already there, right? So this is du over u. Okay. I use yellow all the way. And now I'm going to use green. And that's going to be 4 over u squared du. Okay. All right, the first integral is ln absolute value of u, and the second integral is rewriting that as a term with negative exponent, 4 times u to the minus 2. Okay, so the integral of that is 4 times u to the minus 2 plus 1 divided by minus 2 plus 1. Okay. So let me use white here. Minus 4 over u plus c. Okay, plus c. All right, so I'm going to write the final shot down here. Okay, so ln of u, ln of x squared minus 4x plus 4 minus 4 over x minus 2 plus c. Okay, there we go. So that takes care of the indefinite integral. So now I'm going to go back here and write that as ln of x squared minus 4x plus 4, right? minus 4 over x minus 2. Lower limit is 3, upper limit is 5. Okay, that looks good. All right, so I'm going to plug in 5 here. So ln of 5 squared minus 4 times 5 plus 4. 5 squared is 25. You can use your calculator, by the way, anytime you want. You can pause the video and go slowly with your own pace here. The first term here is going to spit out, let's see, 5 squared minus 20. That's 5. 5 plus 4 is 9. So here we go. ln 9. And I don't need the absolute value sign for that. ln 9. Minus 4 over 3. Minus, I'm plugging in 3. Let me just, so I rewrite this to save space. Okay. So now 3 plugged in, 3 squared is 9. 9 minus 12, negative 3, plus 4, so it's ln 1, minus 4, okay? ln 1 minus 4. So simplifying this, well, first of all, ln 1 is 0. And by the way, we generally want the exact values in the final expression. I do not recommend you to find, let's say, ln 9 with decimal places. I just want to leave it as is to get to the, like in the final form, I want to have the exact value, okay? Okay? And that implies that you have the integral value to be ln 9 plus 8 over 3. So now in the final result, if you want to find a numerical value, yes, go ahead and use your calculator and get the number with decimal places. But in general, we don't do that way. We just leave it in that exact form, and I can go ahead and type here my result. And if you use your calculator, so this should be 4.864. Okay. Well, again, only if the question is asking you to write down the final result with decimal places. All right. And finally, let's look at part D. So we have 7 to the power of x squared minus x squared plus 2x, and you have x plus 1 dx at the bottom. So this is like one of those integrals that we had in the basic integration rules. Okay, so it's number 7. Okay, so a number raised to the power of u du is integrated as like 1 over ln of that number raised to the power of u plus c. So I'm going to try to use this formula towards this problem here. But again, as always, I'm going to rewrite this as an indefinite. Well, this is already indefinite integral, and I think I forgot to put the limits here. So let me check the limits real quick. So the limits would be 0 and 1. Okay. So sorry. All right. So 0 and 1. All right. So 7 to the power of x squared plus 2x, x plus 1 dx. Okay. So here, if I call the top to be u, the derivative of that is going to be 2x plus 2, which is twice of this quantity here. So the good news, again, here is that if I call the top to be x squared plus 2x, du is going to be 2x plus 2 dx, but that is equivalent to me saying that 2 times x plus 1 dx, okay? So therefore, this integral is converted into 7 to the power of u and 1/2 du, okay? So let me just put the 1/2 out of the integration so that I can do that integration in one shot. 7 to the u du. So 1 over 2 ln 7 to the u plus c is the integral of this term. And putting u back here, 7 to the power of x squared plus 2x plus c is the final output of the indefinite integral. All right, so let's go back and write down the definite integral here by using the fundamental theorem of calculus. Okay, so 1 over 2 ln 7, 7 to the power of x squared plus 2x without c, obviously, 0 and 1. And I'm going to plug in 1 first. And 0 next. So that's going to be giving me 7 to the power of 0. I'll just write it, but it's 1. Okay. All right. So in other words, if you factor this out, this is 7 cubed minus 1. Okay. That takes you to 171 divided by ln 7. Again, we need to keep the exact form. If you want a approximate form, you can go ahead and use your calculator right at the end. That's equal to 87.877. Okay, so that's the final output. All right. That makes the end of the video. Thanks for watching. I'll see you in another video. Bye.